Hi friends, good morning. Today we are going to discuss another section of electrodynamics part 4, that is Guage transformation. Right. So we know electricity and magnetism are interconnected, and we studied corresponding we have a scalar potential A and a vector potential A. This is magnetic vector potential, this is electric potential, right? Now Gauge transformation means in classical mechanics time we studied if Hamiltonian is sum of initial Hamiltonian plus a perturbed Hamiltonian. Similarly, for potential, this vector potential A dash, we take A plus lambda, A plus alpha. This is a variable constant vector potential, right? And scalar potential varying with a parameter beta, right? Now, if this transformation, we know del cross A is equal to B, B dash is equal to what? Del cross A. Now, what is new A dash? New A dash we can take as A dash, right? So, B dash is equal to del cross A dash, that is del cross, what is A dash? A dash is equal to A plus alpha, A plus alpha, right? So that is B dash is equal to del cross A dash, del cross A plus del cross alpha. This is B dash is equal to B plus del cross alpha, because del cross A is B only, right? Del cross is B is equal to del cross A, B dash is equal to del cross A dash, right? This is the formula. Now, if this is invariant means, so by applying a condition like this is invariant. Final and initial magnetic field same means del cross alpha must be 0. Del cross alpha must be 0. Then alpha is equal to gradient of some potential, right? Gradient of del lambda, because curl of gradient of a function only 0. So del cross alpha 0 means, that means alpha means gradient of lambda, right? Now, what is electric field? That is the first condition. Now, what is electric field? We studied E dash, magnetic field E dash is equal to minus del V dash minus dou A dash by dou T. Now, electric field is minus del V minus dou A by dt. That this formula last class we seen. Now, E dash is equal to minus del into V dash is equal to what? V plus beta minus dou by dou T of, right? What is A dash? A dash is equal to A dash A plus alpha, right? Now we can write this as E dash is equal to minus del V minus dou A by dou T minus del beta minus, right, dou alpha by dou T. Now E dash is equal to, this is what? This is our E. E minus del beta minus dou alpha by dou T, right? Now, we studied alpha is equal to del lambda, right? So E dash is equal to E minus, right, del beta minus del lambda by dou T, right? Dou by del lambda by dou T. This I can write as E dash is equal to E minus delta into B plus dou lambda by dou T. right? Now E dash is equal to E means B plus del lambda by dou t equal to beta plus dou lambda by dou t is equal to 0. Then beta is equal to minus dou lambda by dou t. Right? It is this one. Alright. So under Guage transformation, we assigned some increasing vector potential alpha and increasing scalar potential beta, and this variation not affect the initial and final of the magnetic and scalar field, means alpha must be gradient of lambda, beta must be negative differential of negative rate of lambda, right? These are the two conditions we seen. All right, now so we can write, we return a dash is equal to a plus lambda, a plus alpha, b dash is equal to b plus v plus v dash is equal to v plus beta. Now this a plus, what is alpha? Alpha we seen del lambda. What is, so vector, right? Vector. Scalar v minus, we seen this beta is, beta we taken as minus dou lambda by dou t, we derived dou lambda by dou t. These two condition under Guage transformation, if vector potential is variant means it should be a plus the gradient of lambda, and a scalar potential is invariant means that should be v minus dou lambda by dou t, right? Now let me do some problems based on this, and before that see, so Guage transformation by giving del lambda and dou lambda by dou t estimation, what condition it is invariant we see. Now see, a changes to a plus r, r changes to where r given r of t r cap, right? R is a vector. Now a dash is equal to, see, a dash is equal to a plus del lambda, you know, right? Now what we seen, we seen a dash is equal to a plus del lambda. What is del lambda? Del lambda is, so we can write a dash plus alpha. Now a is equal to a dash plus, what is alpha? This only, r vector. Now a dash is equal to a dash plus, what is r vector? r cap, r cap. Now alpha is equal to what we studied, dou lambda by dou r, right? If it is invariant, alpha is equal to dou lambda by dou r. Okay, so we write dou lambda by dou r instead. What we got, right? This alpha vector is, this is alpha vector, so dou lambda by dou r cap equal to r cap. Then r cap cancel. Then what is lambda? Dou lambda is equal to r dou r, integrate to both sides, lambda is equal to r square by 2 plus c. Now what is v dash? V dash is equal to v minus dou lambda by dou t. That is v dash is equal to v minus dou by dou t of what is lambda r square by 2 plus c. Then v dash is equal to v minus c dou by dou t of r square doing 2r dou r by dou t. That is 2 cancel. Then dou r by, so r dou r by dou t, right? So this is the equation, right? All right, now let us go to another question. See, the vector potential A is equal to k e raised to minus at r cap. Now corresponding to electromagnetic field changed to a dash is equal to a plus alpha we studied. Now what is a dash? A dash they given minus 3k e raised to minus 80 r cap equal to what is a value? K e raised to minus 80 r cap plus alpha. Then what is alpha? Alpha is equal to this come here minus 4k e raised to minus 80 r cap. Now what is alpha? Minus dou lambda by, right, minus dou lambda by dou r cap. That is only alpha we derived, right? So that is equal to this, right, minus dou lambda by dou r is equal to, so alpha value we substituting, so minus, okay, so here plus alpha. Now alpha we solved. Now alpha we replace here minus dou lambda by dou r cap, r cap cancel. Now we differentiate, this means lambda you get here differentiate, negative cancel, here r on differentiate integration r square by 2 cancel, then 2k e raised to minus 80, right, r square. So this is lambda value. All right. Now similarly what we studied, similarly we can study v dash is equal to v minus, right, v minus v dash is equal to v plus beta, but beta is minus dou lambda by dou t. This is we seen, right? So v dash is equal to v minus dou lambda by dou t, right? Now we substitute the values. Okay. So lambda we seen, v dash, what is v dash? So v dash minus v, we interested in the change, minus dou lambda by dt, 5 dash minus 5 only asking. Okay, that is equal to minus dou lambda by dou t. Lambda we solved with respect to t u do means what is minus, so dou by dou t of lambda value this substitute 2k e raised to 2ka e raised to minus 80 r square. This with respect to t u do means 2 minus come 2ka, right, 2ka with respect to t do means r square no change, right, r square no change, then e raised to minus 80 on doing e raised to minus 80 into, right, into minus a. All right. So 5 dash minus oh, sorry, here already dou lambda by dou t value only given, so directly you can write minus dou lambda by dou t value only given, right? So lambda we already solved, so v dash minus v is equal to 2ka, right? This is lambda we derived before, right, that is minus of dou by dou t of, right, so lambda value what we seen, 2k minus 2ka, right, 2ka e raised to minus 80, 2k e raised to minus 80 r square, right? This is the lambda value we solved. Now v dash minus v is equal to minus 2k r square, you take e raised to minus 80 on doing e raised to minus 80 into minus a, then 2ka r square e raised to, right, 2ka r square e raised to minus 8, right? That is the answer. All right. All right. Now let us go to, so we seen Coulomb's gauge is del dot A 0 and Lorentz gauge condition is del dot A is equal to minus mu 0 epsilon 0 dou V by dou t. This both in previous class we discussed, right? What is Lorentz gauge condition? What is Coulomb's gauge condition? Coulomb's gauge condition means del dot T A 0. What is Lorentz gauge condition? Del dot T is equal to minus mu 0 epsilon 0 dou V by dou T. And we derived this equation also last class, right? This is the equation connecting potential and scalar potential and vector potential. Now suppose this condition you give here, what happened? See, del dot A is equal to minus mu 0 epsilon 0 dou V by dou T. Here del dot A minus mu 0 epsilon 0 dou V by dou T you put means this cancel. Then this part only remaining. Del square A minus mu 0 epsilon 0 dou square A by dou T square equal to minus mu 0 J. Now, if A you replace with V, then del square V minus mu 0 epsilon 0 dou square V by dou T square is equal to, here minus rho by epsilon 0 come. Instead of J, volume charge density rho come. Instead of mu 0, 1 by epsilon 0 come. Look into this equation. Generally, you can write del square x minus mu 0 epsilon 0 dou square x by dou T square is equal to some equation, right? So some charge density into some constant, right? So this operator, you can say this operator is, so that is known as D'Alembert's operator, right? So you can write this operator as, what is this operator? Del square minus mu 0 epsilon 0 dou square by dou T square. This operator is known as D'Alembert's operator, right? So generally you can represent this equation as, suppose this operator I am representing like a box square, and here this operator after A only, right? If you put A here, then this is D'Alembert's operator square A, that is minus mu 0 J, or this you can write as in terms of scalar potential minus rho by epsilon 0, right? All right. So gauge transformation. Now the scalar vector potential of a constant electric field, magnetic field given. Now we should check the Coulomb's gauge condition and Lorentz gauge condition, right? Coulomb's gauge condition del dot A 0, then del dot A is equal to minus mu 0 dou V by dou T. So that satisfy or not, we have to see, right? See, first of all, what is A? A is equal to first I am checking, remaining you can do on the same way, right? So here satisfy Coulomb's gauge or Lorentz gauge condition satisfying or not, we have to check. Here phi 0 given, then definitely dou phi by dou T is equal to 0, right? Phi 0 means dou phi by dou T. Now divergence of A0 or not, how we check? Divergence of A. See, suppose half into B, you take a constant vector they telling. Scalar vector, constant electric field and constant magnetic field. How we represent a constant magnetic field? B0 x cap y cap plus z cap. R vector you can write as x cap, R is equal to x cap plus y cap, position vector, plus z cap, right? So this is the vector, okay? Now half into B0 you taken out. What is here component? X cap, y cap, z cap. What is coefficient of 1, right? Here x, y, z. Then what you get? Half B0 into right, this is A given like this only, half B0 into x cap into z minus y cap into z minus x, alright, plus z cap into, that is y minus x. Now this is a, right, now del dot a you find means I cap dou by dou x of this, right, that is 0 because here no x component. Dou by dou y of this part, here no y component, so that is 0. Here no dou by dou z, here no z component, then this also 0. Then what is del dot a? 0. So divergence of a, that is divergence is I cap dou by dou x plus y cap dou by dou y plus k cap dou by dou z. That is in dot product with this. So dou by dou x of x dot x, x cap dot x cap 1 dou by dou x of this 0. Y cap dot y cap, that is 1 dou by dou y of this is 0. K cap, this z cap dot z cap 1, but dou by dou z of this is 0. Then del dot a 0. And phi given 0, dou phi by dot 0. Then what is the final condition? Dou phi by dot 0 means, right, this here del dot a 0, dou phi by dot means scalar potential only phi. This part is 0, del dot a 0. Coulomb's gauge del dot a 0. Then both Coulomb and Lorentz gauge satisfying. Now next case, what is given? See here, 5 given E dot R. See 5 given minus E0, say E0 xi cap plus y cap plus z k cap, and R is xx cap plus y cap plus z cap. Okay, now that is minus E0 into x plus y plus z. Now dou phi by dou t you find means not equal to 0, right, because x, y, z's are variable, right. So first condition not satisfying. But of B cross R we already seen, of B cross R already we find first problem del dot a 0, then first one is satisfying, right, first one is satisfying. Now third condition, minus E0 dot R we seen, first condition not satisfying, but A0 means del dot A definitely 0, then this is both satisfying, alright, both Lorentz and this satisfying, right. Hope you understood this gauge transformation area. So this is the last area. Okay, thank you.